All right, so 4.2, it's got Rolle's theorem, and then the one that's the most important is the mean value theorem. Okay, Rolle's theorem has three things that have to be true for it to be true. It says if f's a continuous function on the closed interval a to b, and it's differentiable from a to b, and f of a equals f of b, then it says there's some number c in between a and b, so f prime of c is 0. Pretty much common sense, huh? All right, so if we get back to Rolle's theorem here, Rolle's theorem is nice to know, but it's Rolle's theorem led to the mean value theorem. And here was the three hypotheses, and this is in page 212 in your book, but here's an example. Let's say here, like here's f of a, here's f of b. They're equal, and the graph is continuous and differentiable, but it has to change direction somewhere. Right? Here, f of a, f of b, change direction twice in two places with the first derivative 0. This one's got 1. So Rolle's theorem has to have all three things to apply. Function has to be continuous, has to be differentiable, and f of a has to equal f of b. So here's a perfect example of Rolle's theorem. Do we find all values of c that satisfies Rolle's theorem where f of x is x squared minus 6x plus a? Of course we can, right there. So first thing we want to check, for Rolle's theorem to apply, f of 2 has to equal f of 4. Now if I put 2 in here, I'll get 4 minus 12 is negative 8 plus 8, I get 0. If I put 4 in there, I get 16 minus 24 is negative 8 plus 8 is 0. Is it? You know, I've noticed with these guys, a lot of the, like Casey, you're saying they're doing the same problem. Yeah. A lot of them, they like recycle or share problems. Like the high school I teach, we have a book by David Cohen. A lot of his questions are the same as the questions in that. Questions that I picked out of that book for examples for notes turn out to be homework problems in this one. All right, so f of a equals f of b. Polynomials are always continuous and differentiable, so then we know for sure somewhere in between 2 and 4, this function has a derivative that equals 0. So we take the derivative, and we get 2x minus 6. So all we're looking for is a value of x that makes this equal 0. They're calling it c, but we can keep it x if we want. We set this equal to 0, add 6, divide by 3, x would be 3. So at 3, the first derivative is 0. So basically, we're doing the same thing. We're looking to see where the first derivative equals 0, but we're sort of testing the three hypotheses first. If those three things are true, then we know there's at least one value in between a and b, or in this case, in between 2 and 4, when the derivative is 0. How about this one here? Yeah, it was just 3 was the answer. Well, anytime it's a polynomial, it's continuous and differentiable. So if there's not a fraction and there's not a fractional exponent, it's continuous and differentiable. Well, Rolle's theorem is saying that if f of a equals f of b, and the function is continuous and differentiable, then somewhere in between a and b, the first derivative equals 0. So this is sort of a way without first have to actually try to find it, we know for sure this graph changes direction somewhere in between 2 and 4, if those three hypotheses are true.